right, as we take a look at this polynomial and inverse review, a couple of things to take note of. We are going to be doing our dividing in both of the ways that we learned about yesterday. This is not going to be a pick-em type situation. So what we're going to do is for 1 through 3, we're going to do long. And for 4 through 6, we're going to do the synthetic that everybody likes here. Okay? So as we start to take a peek at this, and some of you start to at least get that jotted down, when we get to 1 through 3 with the long, okay, we don't have to worry about sign issues like we do with the synthetic on switching our sign here. All we're going to do is get this written out so we can start our side work. And again, when we're doing our side work, my first step is always taking my first term, my x to the third, dividing it by my first term here, which gets me x squared. Now, as I write that down, I am going to make mention of one other thing. I need to watch when I'm doing this to make sure that I don't have holes or gaps, and we talked about this before. So I look here and I look at my degree and I see my degree is 3. So 3, 2, 1, 0. It goes down one step each time. However, if I see something else and we're actually going to do number 4, I look at this and I go 3, 2, uh-oh, there's not 1 here. That's where I'm going to have to fill in a 0 for that spot to make it work. But we'll talk more about that in a little bit. So once I get that, change up colors here. What we're going to do from there is we're going to take our answer from number 1, get the x plus 8 up there, and then distribute that through. And what we get for that answer is what we're going to tuck underneath over here. And like we talked about yesterday with our old school division, we're going to subtract that. So my first terms will always cancel. At least they better. 11 minus 8 is 3. And we keep everything else the same. And we start the process over. So, same thing again. I get down to here. I take my first term that's left. Divide by x. That's the part that's not going to change. Again, when we do that, we subtract our exponents. That in up here, and then we just keep this pattern going. Take my answer from 1 times my divisor, distribute it through to both terms, and then take that value, tuck that underneath here, subtract. Again, those should cancel. 30 minus 24 is 6. And it looks like we're going to have to do it one more time. We talked a little bit yesterday about I've got to keep doing this until this exponent is smaller than this one. If they're the same, I can still do it. So, one more time. First term, take that, multiply it times my divisor, tuck that underneath, and subtract. Now, if I get through here and I have something left, and I'm going to this time, if I didn't have anything left, that'd just be my answer. But I do have something left. So the 4 just gets put over my divisor, just like I would with a number, and that's what long division is going to look like. So we would do that same thing for number 2 and number 3. Okay, just kind of work through. If you want to do your scratch work on a different sheet or something like that, that's okay. When we get to number 4, this is the part that most of you are probably going to like a little better. Because once we get down to here, now I don't deal with all the variables and all the side work anymore. I have to remember that I'm going to take the opposite of my divisor here. So I'm going to use the 5 in the little box. And when I come over here, I'm going to take my coefficients. If I don't see 1, it's a 1. And I've got to watch for my degree order. So 3, 2, I don't have an m or an m to the first, so I've got to use a 0 in that place. Otherwise, it's going to mess this up. So like we did yesterday with the synthetic, my first number just gets brought down, so I like to use the arrow. Multiply that times what's in the box. Tuck that in the next place, and add down. Negative 5 plus 5 is 0. Okay, multiply it times 5 is 0, and add down. Multiply times 5 is 0, and add down. Now when I get to here, now to get it into the form at the end that I need to get it back into a polynomial, we go down 1 degree from what we started with. So I started with m to the third. So I do m squared, then m, then my constant term. You can even put m to the first there if you wanted to. And then this is going to be my remainder. If I had 0, there wouldn't be 1. But I do. So my remainder, again, is just putting that over my divisor. Not just the 5, okay? Not negative 5, but the entire m minus 5. And I'm set. And since there are zeros here, you could write it as just m squared plus 6 over m minus 5. That would work a-okay as well. Okay, so that's our division, both long and synthetic, when it comes to those. Inverse. Reminder, 2 steps to this. Switch the x and y. Solve for y. Okay, so this time I'm going to jump in on number 7, because again, a lot of this is Algebra 1 skills. Remember, h of x, f of n, all this fancy stuff, fancy way of saying y equals. So here, my first job, switch around the x and the y. Ooh, now we got a challenge. Because now on this one, I need the opposite of a 5th root, because this stuff's all in radical jail. I got to get it out of radical jail first. So, if this were a square root, we'd square it, right? But the reason for that is then my root, or my index, and my exponent would be the same. They'd be opposites, or inverses. So that's what we're going to do here. Because the 5th root and the 5th power would take care of that for me. Gets my y minus 1 over 2 out of radical jail. I got my x to the 5th on the other side. And now we just go straight up algebra. Get my fraction out of there. Opposite of divide is to multiply. So I've got 2x to the 5th equals y minus 1. And since the goal is to get y alone, we will add 1 to each side. Again, 2x to the 5th and 1, not like terms. We're not going to put those together. And so I finished that off. Okay, but I got to keep using my algebra skills to get there. Okay, so switch the x and y, or in this case, you could even make that 3x instead of n if that's confusing to you, and then get those set. State if the given functions are inverses. Does f of g of x equal x, and does g of f of x equal x? Okay, and we talked before on several occasions about how with these, first, f of g of x, which means plug g into f. Okay, that's what this means. So, I'm going to take my g, and it goes in where that x is at. Everything else stays the same. So the negative 4 is still there, but now for the x, we replace it with our g function, which is 3x plus 2. Everything else, plus 20, and the 5 stays the same. And now it's just simplifying. So I'm going to distribute my negative 4 through. I'm going to combine my like terms. And I see that's as far as I can go, but does that equal x? No. So I'm done. They're not inverses. I don't need to do the f into g. Okay, the only time I got to do that second step is if I get equals x on this one. And then I would do the opposite. So to get yes, we do both. Both work. G into f and f into g. But otherwise, once you see a no, it's no for everything. But again, we've seen that a couple of times now. That should be starting to work a little bit more. Or again, you can kind of look at the key if you're trying to see what's going on there. And then finally, as I lose all my papers all over the place, find the inverse of the function. Okay, we're going to do 13. Whoa. Then graph the function and its inverse. Okay. Again, y equals. Find the inverse. Switch x and y. And we're solving for y. We got a little bit easier to solve for y this time. That's good. So I've got to isolate. And as we've talked about also, when we're solving for y, remember, we're wanting this to be in slope-intercept form. That makes it easier to graph. So here, notice I put a 1 in front of my x. So I remember this is going to be 1/3 x. We'll talk about the 4/3 here in just a second. So then we're going to graph them. And what I'm going to do on mine, because I have colors, my colors have kind of disappeared over time here. So I'm going to use black for my initial graph here. So I plot my y-intercept at -4. And up 3, and 1, up 3, right 1, up 3, right 1. Get that graphed. And I said before, what you would have as an option would be if you were having issues with your graphing, if that's not your friend, you could go to the graphing calculator to get some assistance. Type in your 3x minus 4, pull your chart up, and use those coordinate points, 0, -4, 1, -1, 2, 2, 3, 5, to help you. Okay, there's nothing wrong with that. Now let's get to our second one. This is a little more interesting. You're like 4/3. What? Okay, 1.33. Now again, I have options here. I could attempt to go up a little over 1, put a dot, okay, and then go up 1 and right 3, up 1 and right 3. And when I run out of room, I can do opposites of both. Down 1 and left 3, down 1 and left 3. Or if you're like, Harty, you lost me at 1.33. Okay, if I lost you at 1.33, calculator can be our buddy. Make sure your fractions have parentheses. Pull your chart. And just use the whole numbers that are there. You know, -1, 1, 2, 2, 5, 3, and connect your dots using those. So here, I get that drawn in. And remember, why does this all work this way again? Because of our y equals x line that it reflects over. And you can actually see how these points are going to be the same distance away from our values here, okay? It's not quite as obvious since I used the dots instead of using the chart. It would have been a little easier, but let me actually put the chart values on. I don't want to leave you hanging. So -1, 1, and 2, 2, okay, that was a 5, 3. I want you to be able to see this a little bit easier. So as I start to look, now I can see a little bit more of where those dots are going to be as opposites to each other. Okay, so I can see it that way as well. We're starting to head in towards our next quiz. We'll be looking at a quiz preview tomorrow. So if you're still having questions, come in, see me, ask some questions. Thank you very much.